This is a roulette wheel, a common gambling game in casinos. A ball is placed onto the wheel, and the wheel is spun until it stops. The ball falls into one of the 38 slots. There are 36 numbered slots, plus a 0 and a double 0. You win if it falls into the slot with the number you picked. Therefore, the probability of your number winning is 1 out of 38. Let's bet $1 on lucky number 13. The standard payoff is $35 if our number wins, and nothing if your number loses. Ready? Spin. So close, yet so far. Well, what would happen if you played this game over and over for a long time? Well, you would expect to win once every 38 spins, on the average at least. So you would be paid $35 every 38 spins. On the average, each spin would win $35 divided by 38, or about 92.1 cents. This is what we call the expected value. In the long run, you would expect to win 92.1 cents for each $1 bet. Now, you could play once and win $35 right away, or you could play 1,000 times and lose all $1,000. But in the long run, you would win 92.1 cents for every dollar you bet. The casino, on the other hand, wins the other 7.9 cents of every dollar. In this card game, we will win a prize based not on a single desired outcome, but on groups or combinations of outcomes. We are going to turn over 3 cards, one at a time, from a standard deck of 52 cards, and depending on whether we have 3 red, 2 red and 1 black and 2 red, or 3 black cards, we will win different prizes. As it turns out, there is more than one way to get these outcomes. From our deck, we turn over the first card. This card could be red or it could be black. Now we turn another over. Again, this second card could be red or black. Finally, we get the third card, again either red or black. Although we have 8 possible paths in our tree diagram, notice that if all we care about is the combination of how many reds and how many blacks, we can group some of the outcomes together. Here we find that we have grouped the 8 possible outcomes into 4 groups. 1 outcome of 3 red and no black, 3 outcomes of 2 red and 1 black, 3 outcomes of 1 red and 2 black, and 1 outcome of no red and 3 black. The probabilities of each group is therefore 1 out of 8 for all red and for all black, and 3 out of 8 for 2 red and a black, and for 1 red and 2 black. Let's analyze a version of this game where the player spends $5 to play and either wins $10 for getting 3 red or 3 black cards in a row, or wins $2 for any other combination. Here you can see the tree diagram with all 8 possible outcomes. As we just saw, we have a 1 out of 8 chance to get 3 red cards in a row, a 3 out of 8 chance of 2 reds and a black, a 3 out of 8 chance of 1 red and 2 black, and a 1 out of 8 chance of 3 black in a row. Now, if we play this game 80 times, in how many games would we expect to give $10 prizes away? Well, we'll do this on the average 1 out of 8 times for the 3 red cards and 1 out of 8 times for the 3 black cards. We add those probabilities together and multiply by the 80 games, and we see that we would expect to give $10 away 20 times in 80 games. How many games will win $2? On the average, 3 out of 8 games will result in 2 red cards, and 3 out of 8 games will result in 1 red card. So out of 80 games, we expect to pay out $2 in the remaining 60 games. Would we make a profit in the long run? That is, what is the expected value of the profit after 80 games? Well, our income, the money we collect, is $400, while we expect to pay out 20 $10 prizes and 60 $2 prizes for an expense total of $320. Thus, we expect a profit of $80 in 80 games, or $1 per game.